Alright, in this video, I'm going to show you how to get the OpenCV library. OpenCV is a library, open source of course, created for processing certain applications that are related to computer vision. Um, things like video processing, image processing, 3D reconstruction, camera calibration, and things of that nature. We're going to use this OpenCV library to be able to write programs that work on pixels as well as regions on the images and videos. And we can also parallelize the operations that we perform on pixels, regions, and objects in the images, because image processing and processing images is essentially one of those areas that has a lot of parallelability, essentially a lot of kinds of things that we can do in parallel and utilize our graphics cards and parallel processing units to be able to perform interesting applications. The first thing to do is to acquire this library. So you would have to go to opencv.org, which is the website where you can get documentations about OpenCV, support, and of course the library itself. When you go onto the OpenCV page, you will see to the right side there are the latest downloads, and the latest version that's recently released is 2.47.7. And you can go and from the links choose the one that is related to your operating system, to your platform, and then when you click on it, then it takes you to SourceForge, and there you can get the library in the form of a compressed file and download it onto your computer. Alright, now that we have downloaded the OpenCV library, essentially the installation file, in some convenient location, the next step is to extract this library, basically to install it. This library does not require any certain kinds of operating system installation, really, at least on the Windows. And if you're using Linux or Mac operating systems, iOS, please go on the OpenCV documentation and follow the steps that are required to install this the libraries on your machine. For now, I'm going to install this on my Windows, Microsoft Windows 7. Double click on the OpenCV 2.4.7, the executable file, and then run. And this will take you and extract these OpenCV files on a local folder. Once the files are extracted, go and find where they were indeed extracted. They should be on the same level as the OpenCV installation files. Double click on the OpenCV folder and you'll see there are two subfolders. There's the sources subfolder and then the build subfolder. The sources subfolder contains all the source files for your OpenCV project and the libraries. So if you would like to rebuild and create static libraries out of the OpenCV library, you will be able to perform your compilation and linking of this library manually. And the build library contains the binary files and the library files, the dynamically linked library files that you will need to be able to write your own programs using the OpenCV. Essentially, we will be using this build folder, the contents of the build folder in our system, in our programs. The include folder contains the OpenCV header files for C++. You see OpenCV and the OpenCV version 2, which will include and have all the header files that you might need to be able to write computer vision programs. If you go on to the build folder again, you will see two folders at the bottom, x64 and x86. These are essentially the binaries and the dynamically linked library containers for the 32-bit and the 64-bit OpenCV libraries that you will use in conjunction with your Visual Studio projects. If you have a 64-bit operating system and you want to write 64-bit applications, you will use the x64 libraries, and similarly for 32-bit, you're going to use x86 folder contents. If you go into the folders, either 32-bit or 64-bit, you'll see two folders, Visual Studio 10, Visual Studio 11. Visual Studio 10 contains the files that you will need to use if you were using Microsoft Visual Studio 2010, which we will be using. If you were using Microsoft Visual Studio 2012, you should use the contents of Visual VC 11. So I'm going to VC 10, and here you see static libraries, and you see the library files, and also the binary dynamically linked libraries. And I'll show you how you can link to OpenCV in your Visual Studio. We're going to basically use the 86/VC10, and then we're going to use the lib folder in our additional libraries of our project, and then the bin folder in our out directory, so that we'll be able to compile our project. So what you need to do at this point is to move this OpenCV folder that is extracted from the OpenCV application file that you downloaded, the compressed folder. You need to put it in a location that is convenient and accessible. For my projects, usually the projects that deal with the digital gaming and simulation program, what I will do, I have a folder called gaming SDKs, and I usually put my libraries, my software development kits, and OpenCV here is a software development kit that I will be using. I use those in the gaming SDKs folder. So as you see here, I have my gaming folder, and what I'm going to do is I'm going to cut and paste my OpenCV library into my gaming SDKs. Now next, I'm going to show you how to set the environment variable for this directory where you have your OpenCV files and libraries, and then how you use those in Visual Studio 2010. Okay, now that we have our OpenCV installed and copied into a convenient location, we need to add the path to the Visual Studio and the platform that's appropriate to our Visual Studio and platform, either 32-bit Visual Studio 10 or 64-bit Visual Studio 10 or Visual Studio 2012 32-bit or 64-bit. Now notice the location I have is C, Gaming Programs, OpenCV, Build, x86, VC10. So this is the folder location that I will be using, and I will create an environment variable for it so that in my projects, when I'm including header files and additional link folders that I need to compile against and to link against it in the project, so I could essentially use them appropriately. So I'm going to copy the path here and then click on Start menu and type in command to open up a command window, and then I'm going to use the command setx OpenCV _dir underscore 32 underscore VC10. So OpenCV underscore dir underscore 32 underscore VC10 will be my environment variable, and the location for it will be the value where my gaming programs OpenCV folder is. So it's going to be C colon gaming programs OpenCV build x86 VC10. This way I'm going to associate the build folder for Visual Studio 10 32-bit files and libraries to the environment variable OpenCV underscore dir underscore 32 underscore VC10. Now when you type this, this is going to create an OpenCV underscore dir underscore 32 underscore VC10 environment variable for me, that then later I can use that path in my Visual Studio to be able to associate my include libraries, my linked libraries, and my static and dynamically linked libraries. Now we're going to go into the Visual Studio, and in Visual Studio I'm going to have to create an empty project. So for this I'm going to show you as a test project how you can set it up, and then we'll run this program and we make sure that it works. It's going to be a console application, and the steps are going to be similar. We need to do three things. Actually four things. One is, once we have a project created, is to go in the properties of our project and associate the header files, the location for the header files for our OpenCV applications, to be able to find the OpenCV header files in Visual Studio C++ options. In the link options, we need to link to the location of the lib folder of our build that we're going to use, and add the OpenCV lib files. And finally, we need to go to the debug options and add and replace essentially our out directory to where the dynamically linked libraries are, so that our operating system will be able to find them. So I'm going to create a new console application, and I'm going to basically create a new folder in my Visual Studio projects and then call it OpenCV projects. And then the OpenCV projects, I'm going to create a project 1, and press OK, press next, and choose an empty project. Okay. So this is my project that I created, and it's going to be in the documents, Visual Studio 2010, projects, gaming, OpenCV projects, project 1. So this is where my project is located. I need to associate the properties for this project. You can either go and use it globally in your Visual Studio or locally. So the first step is the debugging option. We need to change the working directory, the Visual Studio options, and C++ options, and then the linker options. To be able to do this, I'm going to right-click on my source files and add a new item. And I call it my test application 100. Then right-click on the project. Under the properties, I'm going to go to the debugging section and change the project dir to the environment variable we set for our OpenCV, which I called it OpenCV underscore dir underscore 32 underscore VC10 backslash binary folders, bin file. Bin folder of that directory is where my dynamically linked libraries are. Next, I'm going to have to locate the location for my include files. To show you where it is, go to the Visual Studio 10 where we have our environment variable set. Now I need to go twice out of this folder, once, twice, and then I'll see the include location. If you click on include, you see where all the include files are. So I'm going to basically use my environment variable that I set, which was OpenCV underscore dir underscore 32 underscore VC10. This is the location where my build files are. Then I need to go 2 folders up and then include. This will include all the header files folders where my OpenCV header files are, so that I could use the include preprocessor directive to be able to access them. The next option is setting up my additional libraries. The additional libraries, if you remember from my build x86 VC10, they're in the lib folder. So I'm going to have to do the same thing that I did with the binaries. I need to do that with my additional linked libraries, which is going to be OpenCV underscore dir underscore 32 underscore VC10 backslash lib. This will associate my libraries locations. Finally, I need to add the lib files, the static libraries against which I'm going to be linking. Now for this project, which is because it's a simple project, I'm going to actually use just 2 libraries, the OpenCV core and the high GUI library files. Let me show you where they are. Again, the VC10 is the folder that I'm at. That's where my environment variable is pointing to. If you go to lib, you see there are a bunch of OpenCV files, library files, object files libraries here. And the name essentially is OpenCV underscore name of the library, the number of the release, and then for your release compilation, you just use the name and number. For the debug compilation, we're going to use the D at the end of the name. So that's the convention that you have here. I'm going to basically put these side by side. So I'm going to add the OpenCV core 24/7D and OpenCV high GUI 24D. Since my active configuration is debug, I'm going to use the code, the library with the letter D. So click on edit and then go to your library, bring in, or what I will do is I will basically copy the name of the library, paste it, and then go back to my folder and then bring in the high GUI underscore D. And these 2 libraries should get me going. If I needed additional libraries, I can go in here and just add them. Now, for the test, let's write our program. Alright, now that we have our project properties set up and our header files and link and binary folders associated with our project, I'm going to show you a quick project, a quick file setup, and make sure that this works. And then from this point on, whenever we need to do image processing, you would basically need to follow the same steps to set your project up to use OpenCV. And I'll also show you in another video how you will be able to set up CUDA, and CUDA is much easier because with CUDA 5.5 and the NVIDIA Insight plugin for Visual Studio, you basically have a CUDA project when you create a new project, so you can actually create that. And then within that CUDA project, you're going to add our additional requirements for OpenCV. So let's get to the OpenCV now. So I'm going to have to go and include the cv.h and the high-GUI.h to my project. Now remember, I added the main folder of the build for OpenCV as additional include libraries, because now that that's added, I can use the less than and greater than sign for my include preprocessor directive instead of using quotation marks. So I'm going to basically go within the OpenCV folder and include cv.h and go again to the OpenCV folder and include high-GUI.h. And this will essentially include all the headers that I need to be able to use some basic OpenCV functionalities. I'm going to also include the I/O stream to be able to use my my I/O stream functionalities of my Visual Studio compiler. Then to make it a little bit simpler, I'm going to add two namespaces to my project. Using namespace standard is pretty standard, and you have used it probably in other projects. Similarly, I'm going to use namespace CD for my OpenCV projects. Then I'm going to create my end function, which essentially is a simple empty function. Now, next step up, I would basically need to go in and create an image, load it up, show it on the screen, and make sure that my OpenCV works. So to do this, I basically declare a variable, call it my image, and I'll make it mat, which is a matrix type with OpenCV. And if at this point, if any of the lines on your Visual Studio is red, then there may have been a problem with including your additional link library, your additional header files, or additional include libraries. Otherwise, you'll be able to, your compiler will be able to recognize that, for example, mat is a matrix class from the OpenCV libraries. Next, we are going to read this image file, and we'll use imread function. The imread function requires two inputs. One is going to be a string, as you see, that contains the name of the file, and then the second is a default is an optional variable, which would be the flags. For example, if you wanted to load a color image or a black and white image, or if you wanted to let the OpenCV decide, and so on and so forth. So for this, I'm going to load up an image, and for this purpose, I'm just going to go from the public image files and use a generic image. So let's go to pictures, and then let's say we want to use the tulips picture. So the location for this is under the user's public pictures sample pictures. So I'm just copying that location, and then I'm going to have to paste it. However, with Visual Studio C++, a backslash character is the escape character. So if you wanted to add backslashes, you would have to type in 2 backslashes. Otherwise, your folder structure is not going to be recognized. So now line 13 here is going to read my image file, the tulips, from sample pictures, from public, from users folder on my C drive. And now I'm going to show this. However, before I attempt to do that, I'm going to basically make sure that my image was indeed red. To do this, I'm going to check to see if my image has data or not. If it doesn't have data, or if not my image.data, that means that the image was not red. So I'll prompt to the user that the image file was not read properly. Otherwise, I'm going to show the image, and I'm going to use imShow function. The imShow function, just like imRead, is going to take two variables. However, the first variable, as you see here, is a string that refers to the name of the window that the image is going to be shown on, and the second one is going to be a mat, an input array. So here, I'm going to call this window 01, and then I'm going to send my image to it. And finally, I'm going to use another function called CV wait key. And CV wait key makes the OpenCV, after it shows the window, to wait for a certain number of time. And if you pass argument that's 0, then that CV wait key waits until the user presses a key. Let's compile this program. And as you see, the compilation went successful. And next we can run this program. So if your compilation was unsuccessful, go ahead and make sure that you address all the errors that show up. If your compilation is not successful because of not syntax errors, but because of link errors, there may be two problems. One may be that your additional linked libraries under the link options is not set properly. Two may be that your files, the lib files that you added, were not added properly. And those were the CV core 24/7D lib and the hard GUI 24/7D.lib. Now we'll run this program, and so apparently my file was not read properly. Let's see why. Oh, of course, the name is tulips, plural, and I had tulip as singular. So let's run my project again, and voila, my program read an image and showed it on a window. Now let me show you what might happen if the three different stages that we talked about are not set properly. Let's go and let's look at my project properties, and let's go to the debugging folder. See, if I don't add my debug out working directory, see, working directory is where my compiler essentially utilizes to be able to create my executable files. Now I need to make this directory to where my binary files for the OpenCV are. That's where the dynamic linked libraries were, so that my compiler will have access to them. If you don't do this, and you attempt to run your program, you're going to get an error that says that the required property is missing or empty. If you set it to a wrong project, let's just add, for example, bins to it, and if you run, you will see that you'll get basic errors. You basically get errors that point you to where things went wrong. Next, let's see what happens if in the linker options I type in the wrong file name. Let's put the letter A before the core. If you attempt to run the program, you will see that you get an error saying that this file is not found. So you need to make sure that all your lib files are also added properly. If you forget to add these lib files to the input of the linker, you're going to get an error, a link error as well. If you forget to add the lib link additional directories, then you attempt to run your project, you will see that you will not be able to find the static library files, and that would be a link error. So I'm going to go and add my additional libraries back in. And finally, the most obvious error is if you forget to add your additional include libraries. So I'm going to eliminate that, and then when you attempt to run your project, you would get the big compile error that says that cv.h was not found. Is because your your include libraries were not added to the additional include libraries of your OpenCV project. If all these 3 steps are done properly, your project will work and you will see the tulips.